All right, functions from functions. So here's what we're going to do. I'm going to define some functions. Let's say f of x. Matthew's not been impressed by our antics today, so we're going to...
You don't like us no more. Yeah.
I'm going to define some functions here. Let's say... And so what we're going to do when we talk about building functions from functions, we're going to take what we're given here. We're going to do some things, maybe add them, subtract them, multiply them, and we're going to make brand new functions from them. And then we're going to talk about their domain, because that's y'all's favorite thing to do, of our brand newly formed functions. All right, so let's say, for instance, this is my function. And just to make it fun, let's make this 2x squared. Oh my goodness, y'all be all right.
You can't be changed up on me after I already
I'm
wrote
sorry.
stuff down.
It's just a little exponent, just a little teeny exponent up at the top. All right. Let's say I asked you to find... First, let's do the domain of each of these. What's the domain of f of x? Come on, y'all. You look for two things to determine domain. What are those two things? Oh my goodness gracious. Okay, yes, but what if I look at just the equation? What am I looking for? What two things restrict my domain?
It's the what?
Close. Close, though. What two scenarios cause problems with x? I'll give you a hint. One's a fraction. Because the bottom of a fraction can't be what?
Fraction or radical?
A fraction and a radical. The bottom of a fraction can't be 0, and the radical can't be negative. Okay? Those are the two situations that restrict my domain. Do I have either of those here?
Technically.
Technically, yeah, because you can't have imaginary. Imaginary is whenever there's a negative under the radical. All right, so looking at this first one, do you have any of those situations? No. So what's the domain?
Negative infinity, infinity.
That's correct. Now look at G. What's the domain there? It's a radical, which tells me there's going to be some restrictions, right? Okay. So, it's what? This needs to be bigger than 0, right? Because that would make it be positive. Bigger than 0 means positive. So if I solve that for x, I know that x has got to be bigger than -1. How do I write that in interval notation? That's correct. To infinity. So the domain of G is this. Now when we start combining functions, we have to also combine their domains. Okay? So what if I asked you, what is what's f plus g? Give it to me algebraically and then let's look at the domain. Well, algebraically, you just write it. 2x squared plus 3 plus the square root of x plus 1. Can you combine anything there? Yes, no, maybe so? What could you combine? That one's under a radical, though. You have to leave it just like that. You can't combine it. If you could, you would, but you can't. So I'll leave it. So that's what it looks like when I add those two functions together. But now, what I want to do is look at the domain. What do you think the domain is of this? New function. Our new function is f plus g. What's the domain there? -1 to infinity. It's a combination of these two. If you leave something out of one of the domains, then you have to leave it out of the combined domain. Are y'all following me? All right. Yeah.
So it's kind of like, We brought it down, like when we were in the I don't know, it's like 5
Trinomial?
grand.
Kinda, yeah. Yeah. Now, what if I multiplied these two things together? What if I asked you what is f times g? What did I have? What was f? X squared,
2x
2x squared. Thank you. Oh my. Times the square root, x plus 1. Is that what it was? Again, this really isn't as much about multiplying these out in this form because there's not that much that I can do. But understanding that this is a new function, how about the domain here? What do you think it is? Come on, shot in the dark. Same thing, same exact thing. When you combine them, you have to combine the domains. Now, you're going to get to the point where maybe what if I did f divided by g? So now I have 2x squared plus 3 over the square root of x plus 1. Again, can I simplify that any? No. All right, so what else cannot happen in the bottom there?
Can't have a radical.
What else?
Okay.
Can't have what in the bottom? What does fraction do for my domain? It can't be 0. Remember what we did before where we said x plus 1 has got to be greater than or equal to 0? How is this different? Because this is my combined domain, but when I combine them, I have a new situation that restricts my domain. Look at this. I can't have a 0 down there. How could I leave the 0 out? Well, it was. See, it's -1 here, but what can I do to make sure the bottom is never 0? Come on, y'all. Look what I did initially. I said x plus 1 has got to be greater than or equal to 0. How do I make sure it can't ever be 0?
What does that mean?
What's the difference? It's not equal to. It can't be 1 here. This domain is different. This domain is different because it's still got this piece in here, but this time I can't include -1. It's got to be a parenthesis instead of a bracket. Does that make sense? A little bit, no. Anytime you have a fraction, the bottom cannot be 0, period. So you have to leave it out of your domain. All right, let's do a couple more. I can tell y'all are just like, oh. All right, let me do a new f and g. Let's say that, actually I'll use a different variable. Let's say h of x is x plus 1. J of x is I'll just make this easy. Oh my. All right. What's the domain of h? Negative infinity to infinity. What's the domain of j? Negative infinity to infinity. No restrictions, right? There's no radicals, there's no square. Do what? Because if there's not a radical and there's not a fraction, it's negative infinity to infinity. There's no restriction, that's right. What's h times j?
Oh, X plus one. I mean,
Mm-hmm. This one I can simplify a little bit, right? I can distribute that 5x through. What do you get?
5x squared plus 5x.
What do you think the domain is here? Negative infinity to infinity. What if I change this, though, and ask you to find h divided by j? What happens? H over j. Now what? How is my domain changed? I can't simplify that any. But my domain has changed some. What's changed about my domain now? X can't equal... If x is negative 5, that put negative 25 in the bottom. X can't be 0. 1/5 would give you 1. So what would you have to plug in for x? You're way overthinking it. What would you have to plug in for x to get 0? 0, right? So x can't be 0. How do I leave a value out of the domain like that? Please tell me somebody can get this. Leave out just one value. The thing in the middle. What thing in the middle? The u in the middle. With the parentheses on either side, right? So I do negative infinity to 0, u 0 to infinity. Does that make sense? All right. Let's do composition then. By the way, while y'all copy that, what's the domain of the absolute value of x? Negative infinity, positive infinity. That is not, that only restricts what? The range, the y, right? Top to bottom, because it can't go negative. All right, y'all ready for composition? This, you should have gotten this in Algebra 2 for sure. Every Algebra 2 class should have gotten to this. But in case not, here we go. Big lesson for a Monday. Do any of you remember composition? No. Maybe you'll remember it when you see what it is. Let's redefine f and g, and I'm going to start easy. Let's do 2x plus 1, and let's do x squared minus 3. What if I asked you to find f of negative 1? What do you do? Plug in what? Negative 1 for what? For x, right? So this would be 2, negative 1, plus 1. We're all okay with that, right? What if I asked you to find f of k? I'm not going to use k. That doesn't look very nice. It's like I'm trying to do something not very nice. Let's say f of p. What would you do then? You just plug it in for x, right? Whatever, the point that I'm trying to get to here is, whatever is in parentheses is what's replacing the x, right? What if I asked you to find f of x minus 1? You plug it in. So I have 2 x minus 1 plus 1. Does that confuse anybody? Whatever's in the parentheses is what goes into place, right? What if I said, what is f of g of x? What is g of x? Do you know what g of x is? X squared. So f of x squared minus 3, because g of x is x squared minus 3. Well, now it looks like what we just did. It's not hard anymore, right? Right? So it becomes 2 times x squared minus 3 plus 1. And now I can clean it up a little bit. I hadn't been doing that with these others, but I can do that now. And I can make this become 2x squared minus 6 plus 1, which is what? 2x squared minus 5. I'm fixing to sneeze. Excuse me, I'm sorry. Thank you. What do you think, if the same rules for combining domains apply, what do you think the domain is here? Negative infinity to infinity. Try this one. Try and find. Can I erase this? Thank you. Y'all are super quiet today. Ooh. It's the blue circle of death. Find g of f of x. See if you can do that one. All right. So g of, it's not f anymore, it's 2x plus 1. So now I'm going to replace this x. Can I simplify that any? How? Tell me what you did. Can you distribute that exponent? Why? Because you're adding in here. Excuse me, you have to FOIL it. That was probably that spider over there jumping around. Did y'all lock that window back? All right, let's go ahead and FOIL this thing out. 4x squared plus 2x plus 2x plus 1. That little minus 3 is still sitting out there by himself. 4x squared plus 4x. Did everybody FOIL it? No, I didn't figure you did. What about the domain? Negative infinity to infinity. Okay, one more. Let's see if you can get this one. Use that same f and g. What was f again?
2x plus 1.
And what was g?
X squared minus 3.
What you think you do? Child, I don't know. Work inside out when you do these. Go as far inside as you can. So 1. I'm plugging 1 into what? Into g. What is g of 1? Can you do that?
You seem like we slow.
No, I was saying in general, can that be done? I was just saying. Oh my goodness, y'all are taking this way too far.
Sit there for like 30 minutes. Like, no, that one right there.
Miss McGeary. Oh, damn, Dora.
Good job. You didn't even know if you picked the right one.
-2. -2. All right, so now look, g of 1 is -2. So now what I'm really looking for is f of -2. Y'all just went way in another direction on that.
Why are you doing it?
Maybe like just plug it into like the entire equation with f and g today.
You can, but you'd have to find f of g of x first, and then you could plug it into the answer. You can. Sure. All right, let me tell you what. Oh, let me show you this because this will come up.
Wait.